So this is part 2 of the review. Jalen charges $9.50 per hour when he cuts grass, plus $10 for transportation expenses. Write a function rule to represent the amount in Y that Jalen charges to cut grass for X hours. All right, so because we're writing a function rule, we know we're going to have something that looks like Y equals mx plus b, where m is the slope and b is the y-intercept. Now, slope and y-intercept don't necessarily make sense in this case. I mean, it does, but really what I want you to think about in a real-world problem or in a word problem, the y-intercept is the starting value, which is true when we graph it too. Like the y-intercept is the first thing we graph. It's our starting point. So when I think about writing functions rules, I like to think of the slope as still the rate of change, and then the y-intercept is the starting amount. So if I was looking at these two numbers, I have $9.50 per hour, and then I have $10 for transportation. The starting value here is $10, and the rate of change is $9.50 per hour. No matter how many hours it takes, he's still going to charge $10 just to get there, and then he's going to charge $9.50 per hour. So this is how I would write this function rule. Which function represents a parabola? Remember back on the last video, we said a parabola is in the shape of like a U. Anytime you have a quadratic function, the shape of the graph is called a parabola. And a quadratic function happens whenever you have it raised to the second power. So if we go back here we see x is raised to the second power. That one is going to be a parabola. If we actually graph these points, we have one at -4, -1, -2, 0, 0, 1, and 2, 2. This is a straight line. If you wanted to graph this one in Desmos to double check, you would have 2 plus x squared. Y equals 2 plus x squared. And you can see that it is in the shape of a parabola. It's a U-shaped graph. But it's easier if you just remember that x squared makes a parabola, then you can just pick that answer out quickly. Which quadratic rule represents the data in the table? So if we're trying to pick out which one represents the data in the table, my first reaction was to plot the points. So at -1, 4, 0, 5, 1, 4, 2, 1, and 3, -4. So if I go ahead and graph these, I'm going to see that I'm going to have a shape that's like this. Now I want to mention it doesn't just stop, it keeps going. So it doesn't just stop right here, it keeps going down like that. So even though your points don't go all the way down, graphs continue. So that will keep going. So now if I want to match it, there's a couple ways you can think of this. Of course you can use Desmos, and we will definitely look at Desmos. But a couple of things that I want to point out just to make your life a little bit easier when you're taking the test. If your x is positive, so if you have a positive x squared, then the parabola is going to be shaped like this. The arrows will point up. If you have a negative x squared, it's going to be upside down. The arrows would point down, down for negative. So since this graph is upside down, since the arrows are pointing down, I know that the x value has to be negative. So I can go ahead and cross out these two answers. And then from here, we kind of narrowed it down. We can also see it crosses the y-axis, if I could talk, it crosses the y-axis at 5, so the y-intercept is 5, but both of these have a y-intercept of 5, so that doesn't really help us narrow it down. So probably what I would do, you could either pick a point and plug it in to see which one it works for, or you could use Desmos. I like to pick easy points. So if I plug in a 0 for x, actually let me not plug in a 0 for x, let me pick a different point. Let's plug in 1, 4. So if I plug in a 1 for x, that should equal a 4 for y. So 1 squared is 1 times -2 is -2 plus 5, that would be a 3. And 3 does not equal 4, so that is not my answer. This one would be my answer because 1 squared is 1, -1, plus 5 would be a positive 4. You could also type this in Desmos and see which one looks the same. And so this would be the correct answer. Wait, let me go back to this. I feel like I kind of did this an injustice. If you see a problem like this on the test, you absolutely do not have to plot the points and graph it. If you're visual, you can graph it and then type them in Desmos and see which one matches. If you are not visual, then use your process of elimination. Well, don't even do that. Just go and pick a point and plug your point in for each of these and see which one it works for. Okay. A 200-pound person burns 450 calories per hour riding an exercise bike at a rate of 15 miles per hour. Write a function rule, so that means we're going to have something that looks like y equals mx plus b, to represent the total calories burned over time by that person. Explain how the information in the problem relates to the function. Okay, so there's some important information in here, and then there's some not so important information in here. The fact that he is a 200-pound person is just a distractor. It doesn't matter if you're 200 pounds or 100 pounds or 500 pounds. All that matters in this situation is how many calories he burns per hour. That's all we need to know to write the rule. So, we could write this a couple different ways. Let me show you a couple of them. The first thing I notice is that he burns 450 calories per hour. So I could do y equals 450x. And if this is all I would have to do to have an appropriate function rule. But it does say explain how the information in the problem relates to the function. So you would have to note that y is the total calories burned. And that x represents an hour, the rate per hour, as long as he's going 15 miles per hour. So x is the rate per hour, and in this case, he's going 15 miles per hour. So as long as he stays 15 miles per hour, he's going to burn 450 calories every hour. So if he bikes for 2 hours, you would plug in a 2 there, and he would burn 900 calories. If he bikes for half an hour, it would be half of that amount. So this is a great function rule. You just have to make sure that you tell what each thing represents. And our rate per hour only works if he stays at 15 miles per hour. So if he increases to 20 miles per hour, he's probably going to burn more calories. And if he decreases to 10 miles per hour, he's going to burn less calories. But we don't really know that information. All we know is this information. So this is our function rule, and this is how it relates to the problem. And that's it. Good luck on your Unit 4 test.